Good morning, Great Lakes Academy Middle Schoolers. Today's date is Wednesday. It is May 20th. And ladies and gents, oh my goodness, I'm excited. I'm betting you can guess why if you're looking at your screen. We have our fourth and final reviewing chemistry experiment here, and it's a big one today. We are making homemade ice cream. You don't need no machines, you don't need any fancy equipment, you just need some Ziploc bags and some ingredients. It's going to be awesome. You want to learn about how to do it? You can do it at home. It's going to be delicious. I already ate my ice cream. It was great. I want to give a shout out to all of you students at home who've been doing an awesome job completing these optional but highly encouraged at-home science experiments. I got videos of elephant toothpaste from 4 different folks. I got Jael and her mom making some over here. I got pictures of Cadence shooting off her elephant toothpaste there. I got a video of Jaden and his mom. They did the normal version without the soap and the toothpaste version with the soap and the food coloring and everything. Plus, I got a video from Jalen and her mom making invisible ink, writing some secret messages, and then revealing it. Props to all of you guys. Watching these videos honestly makes my day. It makes me so happy to see folks, learning and getting hands-on experience with science at home, especially in this, the social distancing time when, hey, there's not a lot else to do with our time. We don't want to just, watch TV and play video games all day. That's no fun. It's awesome to see you guys doing this. It makes me really happy, and it also makes me a little bit nervous because with the addition of Jalen and Jaden, that makes it 13 total students who have done at-home science experiments now. And you guys probably remember a couple days ago, I made a deal that if 15 different students do these experiments, your science teacher is going to cut his hair. Oh, so we're 2 people away. So that should be pretty easy to get at least 2 students to make themselves some ice cream. We'll see. Maybe I'll keep it. Maybe I won't. Depends on you guys. A deal is a deal. I'm waiting for those last 2 videos, and then we'll see what happens. All right. To remind you, we are now on experiment 4. These are the ingredients that we had listed a few weeks or last week of the things that you'll need to make your homemade ice cream. And to kind of orient you on the calendar, today's date is right here. We are on Wednesday, May 20th, doing our 4th and final experiment. And unfortunately for you guys, that means tomorrow you have got a unit test. Ooh, oh snap. All right, I want to give you guys some information about this test coming up because this is the unit test for Unit 6, Chemistry, and we've been in chemistry for a long time now, so it's a lot of information that might be on that test. Here are the details. First of all, it will be all multiple choice. Some of them might be, check off multiple answers, something like that, but it's going to be basically all multiple choice, a Google form, like our other quizzes and tests have been since we've been online. Second of all, it will be around 30 questions, maybe a little more than that, maybe some extra credit in there as well. And third of all, you may use your notes, but not the videos, to help you. So if you've been taking good notes this whole time, then man, you are in luck now. That's going to pay off because you're going to kick butt on the test because you can flip through your notes and look for anything that you have written down to help you with these answers. I also want to give you a sense of kind of what are all the topics covered, all the material that's going to be on this test. And so everything that you see in this grid right here is something that might show up on your test tomorrow. Everything from our basic beginning questions like what is matter? Can't. It's anything that has a weight and takes up space. To the more recent stuff about atoms and molecules, material science. All of these different properties, because we talked about a lot of properties, could show up on the test. All this different stuff to help you study. So you should probably take a second to look through this list and see if there's anything that jumps out at you that you don't feel very confident about, and then go back and study some more about that before tomorrow's test. You might also be asking, Mr. Manta, there's no study guide. How? How can I study for this? How is that possible? Well, if you remember, about a month ago now, in Unit 5, we did a whole video lesson all about science-based study strategies. And we learned that the 2 best ways that scientists have shown have the most evidence help people do really well on tests are these 2. First of all, to quiz yourself at home. And second of all, to be the teacher, to pretend to be a teacher and teach something to somebody else. So we always want to use these 2 strategies in preparation for a quiz or a test. So how can you do that today? Well, first of all, the best way I would say to quiz yourself would be to look back through the exit tickets. You can still go back and open all the exit tickets that we've been having, and you can read the questions, and try to read the questions then without even looking at the answer choices, right? You're making a prediction of what you think the answers are going to be for each of those questions. You're going to try to work out in your head what the right answer would be, and then check, because now when you go back and look at old exit tickets, they'll show you what the right answers were, so you can then quiz yourself and see if you got those right by going through those old answers in your head. The second strategy, right, to be the teacher, the best way I would say that you guys could do this one to study for tomorrow would be to take your science notebook or that list of topics from the last side and hand it over to your mom, dad, grandmother, sibling, someone else around. Then ask them to pick out some of the key words and have you teach them about it. So, for example, you can either use your notebook or you can hand over to mom or dad this list that we're looking at here and have them just pick a topic at random. They might say reactants and products, and then you have to teach them all about that. That'd be an excellent way to study for that test tomorrow. All right, next things up, I want to give some shout outs, some more shout outs to students, not just who are doing their experiments at home, but who are giving me some awesome answers to their classwork questions. Yesterday's second question was asking, would you rather invent a magical device that made things happen faster or slower, and why? How would you use it? I got some very interesting answers from students in all different classes. I had Alante here who said, I think I'd make a device that made things go faster because there's things that you want to go faster, like a wait at the doctor's office. It's true. If you could just press fast forward, it could skip through that whole wait. Madeline, on the other hand, said she wants things to go slower because I want to have more time to be with my friends and family after COVID-19. I like that answer. I think we could all spend some more time with friends and family. I had Quincy here saying that he wants things to happen faster as well, because what if you had to do something you didn't want to do, like get 5 shots? You want to hurry up and get it over with. That's a very good point. Man, you guys really don't like going to the doctor, I guess, huh? I then had Brianna on the other side from Tennessee who said she picked slower because she could live life to the fullest. The more, the older I grow, the more I feel that way, Brie. I gotta say. I just try to take my time slow. Life passes you by too fast sometimes. I had Reg in 6th grade who said he would make a faster machine because he wants to work out faster and get the same results. That's an excellent idea. I hadn't thought of that. And on the other hand, lastly, I had Shavella. And Shavella said, I would use the device to slow down time so I can think about my decisions. Awesome. And so I can do whatever I want during the time being. And that would mean that time might stop so I could go to McDonald's without no one knowing. Hey, it's a very creative use of it. Sometimes you just want to sneak off to McDonald's and not have other people ask you to, bring them something back or something. Excellent answers to all 6 of you guys. I really enjoyed those. All right, that takes us to today's do now. Enough hubbub. Let's actually get some work done. You're going to go ahead, label today's lesson, Unit 6, Experiment 4, ice cream in your notebook, and number 1 through 10 for the do now. Here are the first 5 questions. Pause the video and answer these 5 questions now. Alright, I'm assuming that you've now completed the first 5. Let's take a look at numbers 6 through 10. Pause the video and answer 6 through 10 now. Alright, assuming that you've got that done as well. Let's move ahead. Let's see the answers. Number 1. In a chemical reaction, the stuff you start out with is the reactants. That's a word we got to remember. Number 2, in a chemical reaction, the stuff you end up with is the products. At this point, we reviewed those few words a couple times, so I'm hoping you guys are getting that one now. Number 3 is this word we learned yesterday. Something that you add to a chemical reaction to make it go faster is called a catalyst. Number 4, is melting ice cream a physical change or a chemical change? That is a physical change. Melting, changing states is always physical. And number 5, is dissolving salt in water a physical change or a chemical change? That is also a physical change. I'm guessing this one tricked some of you guys. We said yesterday, dissolving things, making solutions, is always a physical change, and yes, it is possible to undo them. Let's look at 6 through 10. Let's see. Our friend Brock gets some water from the sink. He changes the water's temperature, so it is now below its freezing point. What state is the water in? Well, we learned that a freezing point is the temperature at which something freezes, so if it goes below that, it must be solid. He turned it into ice. For number 7, Sandra gets some water from the sink. She changes the water's temperature so that it is now above its boiling point. What state is the water in? Well, we learned that a boiling point is the temperature where something goes from a liquid to a gas. So that water is now gas. She turned it into steam. Number 7, water boils at 212 degrees Fahrenheit. That means that 212 degrees Fahrenheit is water's boiling point. Number 9, the law of conservation of mass says that matter can never be created or destroyed. And number 10, true or false? A water molecule is made of hydrogen atoms and oxygen atoms. That is true. Our molecules are always made up of smaller atoms that are like the little building blocks that we make molecules out of. All right. Some of you guys are probably feeling this way. You're like, all right, enough science. Did you say something about ice cream? Let's get to it. To this little kid who's patiently waiting, I now say, yes, let's make some ice cream. Let's talk about how you make ice cream first. Ice cream, folks, is a mixture. Remember that most of the time when you combine two or more substances, you just create a mixture. It's only rarely in certain situations that you're able to create a chemical reaction, a new substance, and all that. Ice cream is just a mixture. It is really just a mixture of milk, cream, which is like a heavier, denser milk product, sugar, and any kind of flavorings that you add to it. So like this is a bottle of vanilla. Of course, you can add chocolate syrup or mint or something to your ice cream as well. It's just a mixture of these four things. That might lead you to ask, well, why can't we just mix them together and make ice cream? That's a typo. That should say can't. Why can't we just mix them together and make ice cream? Well, I'm hoping that the answer to this one should be pretty obvious because you guys are some pretty smart students, which is that it wouldn't be cold enough. If you just took these things out of the fridge and mixed them together, it wouldn't be cold enough. You would have ice cream soup, melted ice cream, and nobody really wants that. So you might have another idea, which was, why can't we just mix them? Oh my gosh, why can't we just mix them together and then put it in the freezer? And then you'd have all that stuff mixed together and it would be cold enough, right? Well, to understand that, we have to understand a little bit about how an ice cream machine works. This is a picture of like a professional ice cream machine, the kind that they will have often at restaurants or ice cream shops that makes the ice cream in the back. In this ice cream machine, you pour all the ingredients in top, and then inside, it's almost like a washing machine. There's a whole bunch of chambers and paddles and levers that keep the whole thing moving around all the time. It's always swirling and spiraling around. The reason being that the ice cream needs to move around while it freezes together. Otherwise, you end up with like a solid block of just stuff frozen together, and no one likes that. So if you just mix this stuff together and put it in the freezer, it won't really turn out right. It won't make the right kind of ice cream. So then you might be asking, hey, go away. You might be asking, well, why can't we just mix them together, put our mixture in a bag of ice cubes, and then shake it around a whole bunch? That's a very good question. To that, I say that is a great question. And my friend Bill Nye, the science guy here, he agrees that that is a good question. That's really the crux of our lesson today. To understand why that won't work, we have to think about melting points. Now, we learned about this a while back, right? We're looking at our thermometer here that measures the temperature of things, and this one goes from 0 degrees Fahrenheit all the way at the bottom up to 40 degrees Fahrenheit at the top. Now, we learned that a melting point is a certain point at which if you have something like water, right, water's melting point is 32 degrees Fahrenheit. That means that if you get some water that is hotter than 32 degrees, it's going to turn liquid. But anytime you have water that's colder than 32 degrees, it will be frozen solid and ice. So the melting point is the point that makes the difference between liquid and solid. Water up here and ice down here, right? Here's our problem for today. The melting point of water is 32 degrees Fahrenheit. The melting point of ice cream is all the way down here. It's closer to 15 degrees Fahrenheit. That's a problem because if you follow this girl's recommendation and you mix together your ice cream, you put it in a bag of ice cubes, well, regular ice cubes wouldn't be cold enough to make ice cream because their melting point is too high. You could have ice cubes that are like 25, 30, 32 degrees Fahrenheit. And if you put your ice cream mixture inside of those ice cubes, well, it's not going to be cold enough. It has to be this cold, and the ice cubes might only be this cold. So that's not going to work because their melting point is too high. But we have a solution. Here's the melting point of water. Here's the melting point of ice cream. And here is the melting point of salt water. Salt water you have to make a whole lot colder than even water or even ice cream in order to freeze it. It has a lower melting point than these other two substances. So, since salt water does have a low enough melting point to make ice cream, we can... Oh, this little girl has an idea, which is, why can't we just mix them together, put it in a bag of ice cubes, add salt, and then shake it around? And young lady, that is what we are going to do. That is a great idea. And what Bill Nye has to say is that if we think together and work together, good things are going to happen. I'm glad we came up with this idea together. Now we get a chance to make some ice cream. To the experiment, let's make ice cream. I'm going to pull up the video of that I made earlier today. Ooh, and also as an added bonus today, I have a very special guest. that many of you have been asking to meet. You get a chance today, finally, to can't meet her in person, but to meet Mr. Manta's girlfriend. Watch closely. All right, we're ready to go. Experiment 4 is happening now, and today I brought a special guest.
Hello, everyone.
Who are you?
I'm Amy, or if you are one of my students, I'm Miss Duggan.
Oh, there we go.
And I am Mr. Manta's girlfriend.
Wow. So some of you, a few of you lucky folks, Layla, Jihad, Nevaeh, Janaya, Marcus have already gotten a chance to meet Miss Duggan, but for the rest of you, it's probably as close as we're going to get to the end of the school year with school being closed down. Miss Duggan, what do you do?
I'm a high school English teacher.
Wow.
Y'all.
So you teach like the second best subject is what you're telling me.
The first best subject, but yes.
Okay, but you're helping today with our science experiment. So, do you know what we're doing today?
We're making homemade ice cream.
We are making homemade ice cream. So, as always, I'm going to start off by going through our materials. And we have probably more materials today than we've ever had before, because it's not easy to make ice cream. As we often do, we have a tray to work with, because things are going to get a little bit messy. And we also put in our materials list to have 2 different size Ziploc bags. We have the gallon size bag, the big one, and the quart size bag, the little one. You can keep those off, the sun is there. Go ahead. And then we have all the actual ingredients for our ice cream itself. That is going to include milk and some heavy whipping cream. And if you're following along at home, then making half and half, using half and half would be the same thing. So we're just going to combine equal parts for those. We got a big thing of sugar, of which the internet says to add a tablespoon, but we might add more than a tablespoon if that's okay with you.
That's more than okay with me.
And we got some vanilla. And that's what we need to use to actually make the ice cream itself. But in addition to that, in the big bag, so the little bag is what the ice cream is actually going to be made in, like it's going all inside of here. But in the big bag, it's going to be like our ice cream making machine, where we're going to have a whole bunch of ice cubes in addition to one other secret ingredient, which is some salt. Pop quiz here.
Yes.
Why do you think we need to add salt to the ice cubes that we're making our ice cream inside of?
To lower the freezing point?
To lower the freezing point, because the freezing point of ice cream is below regular water, and so if we just had 32-degree ice cubes, it wouldn't be cold enough to make our ice cream.
Yeah, we need it to be way colder.
Alright, let's go fill up some ice. Alright. Alright.
We got a big old bag of ice.
My hands are really cold now, but we got that set up.
And gloves.
And gloves on hand, because we're going to be having to toss this around. It's going to be really cold, even colder than it is now.
Yep.
So the instructions say to fill up the bag about halfway, so that's what I've got right here. And then we are also, not yet, because I don't want to get our half, or we can do that actually right now.
Yeah.
We're also going to add to it, this is a half-cup measure of salt. I have kosher salt here. You can use regular salt if you want. A lot of people online even use rock salt. Any kind of regular old salt will do.
I was going to do it.
You're going to do it?
Yeah.
You want to do the honors of pouring it in?
Yeah, I do.
Okay. Ta-da! Go ahead.
Okay.
All you.
Do we want to even it out? Do we care?
No, I think just kind of sprinkle it all over the place.
Okay.
Nice. So with that, we've got our ice cream making machine prepared. Set that off to the side and start mixing our actual ingredients. To do that, we're going to get a little baggie, the quart-sized one. And, dear, if you could please measure out half a cup of either milk or heavy cream to start with.
Starting with heavy cream.
Nice.
It's really convenient that you only need a half a cup for this.
Yeah, I know. That's going to be all of our different measurements are going to be the same thing. And it means we're going to have a little salt in our ice cream, but I kind of like that.
I like that too. Brings out the flavor.
Da-da-da. All right, half a cup of heavy cream. Excellent. Half a cup of milk. We're like the next...
Maddie keeps bringing over different toys in hopes that we are piqued. Our interest is piqued.
Maddie featured in the video yesterday. That's our little dog.
So you guys know
she
the
was
pup.
watching the toothpaste getting made. Half a cup of milk. Good pour, good pour. Alright, I'm going to do sugar. And like I said, I think the recipes that that said a tablespoon of sugar also had only a half cup of liquid. Maybe we can do like a nice couple heaping tablespoons of sugar. Make sure our ice cream is nice and sweet. Look at you.
Nice.
1 and 2. Man, this would really suck if this turned out to be salt. And
yeah, don't get your sugar and salt mixed up, ladies and gentlemen.
Rookie mistake.
Won't be as delicious.
And lastly, a dash of vanilla, the good stuff. Because we are making vanilla ice cream. This would also be the point, by the way. So you can use the same method to make like chocolate ice cream or mint ice cream or something like that. And this would be the point where you can maybe add some chocolate syrup or some cocoa powder or some mint extract or something like that. If you want to do toppings like M&Ms or Oreos, I would probably actually say wait till the end and just kind of sprinkle those in at the very end. And then the last part, which the internet also told me it's very important, is we want to get as much air as we possibly can out of this thing. So I'm going to kind of press it down.
And you want me to...
And you zip it. Yeah, perfect. Good teamwork. Oh. Nice. Alright, so we are pretty much set up at this point. Now the next step is that we need to mix this guy up a little bit, get the sugar and all that spread out, and then actually do the ice cream making, which takes a minute. That's the hard work of today. To do that,
Takes more than a minute.
Takes more than a minute. It takes 10 minutes actually. So we are going to drop this guy into our mixture of salt and ice cubes, narrow him down, and then getting gloves on because we're going to spend 10 minutes, I'm going to set a timer on my phone, just shaking the crap out of this. Shake it all around. That kind of gets the ice cream fluffy and aerated, and also like makes it cold enough all over the place that it actually forms from this like strange liquidy mixture that we have into actual ice cream.
Yes.
Alright, ready to go?
Yep. I'll do 5 and you do 5. Or
You can
we'll do...
toss it back and forth. Yeah. You can be silly with it. Cue ready?
Oh, it feels like it's starting to get solid.
Just feel the actual ice cream.
Yeah. And 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Ice cream! For those of you who are able to try this at home, you will also be able to feel yourself how not freaking cold this gets. It's way colder than just regular ice water.
Hi, baby.
Because of all that salt lowering down our freezing temperature.
Yeah, she was. We had a nice
And our melting temperature lower than it would usually be. Alright. It's the moment of truth now, our final bit of extraction. Here, can you please remove the ice cream
Yes.
from the bag?
Yes, I can. Ooh, it feels very creamy.
Oh, careful.
Yeah, that's right.
Nice. Getting some saltwater drippings. Oh my god, that's very salty. It's like seawater.
Ew.
That's good. That's not the part that we're eating.
That's what you get.
Alright, let's see what we find.
Salt and water is
I didn't realize you made it so salty. Alright, in a moment of truth, yes, luckily the bag can still unzip. What do you think the best way? Do you think look at that? That's ice cream.
Yeah, that's definitely ice cream.
That is
I
ice
think
cream,
we should just
folks.
scoop it out.
Scoop it?
Yeah.
Alright, we get our professional science grade scooper. So known as a spoon. It's not too frozen in the bottom.
Right. The hardest part is going to be getting it out of the bag, y'all.
Da-da-da.
Wow, that's very much ice cream.
Let's flip it around because that doesn't have the zipper on that side.
Yeah.
Here, can you try to pull that straight as best you can?
Yeah.
Da-da-da.
Yeah.
Indeed. Da-da-da. Get out of there, you. Alright, I think I can get the rest of it here. In one fell scoop. Get it?
Ha 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 ha.
Ta-da.
Ooh. Y'all, it looks good.
All right. We've got the Barney bowl that we're rocking.
That's right.
We might need to add some pickings later on.
Yep.
All right. Oh my goodness, I'm a mess.
This is the best.
So for those of you trying this at home, I'd be very curious to hear what your ice cream shaking dance playlist ends up being.
Mm-hmm.
We had some Earth, Wind, and Fire and some Chromeo. And
Hi,
Mom has now shown
I'm Silly, your best friend.
Ah.
Mom is now showing up for the taste testing. Say hi, Mom.
Hi, guys.
That's Mama Manta. And you want to get a spoon? You want to use a tablespoon? Like a savage? No?
Savage.
Like a
savage.
savage.
You're looking it out of the bowl.
All right, let's do it.
Should we cheers?
Taste test. Cheers it.
Cheers. That's really good. It's nice. That's
Well,
definitely
That's a perfectly wonderful ice cream.
right.
We're spoiling our dinner.
Mm-hmm.
Oh, yeah.
For science.
Sorry, moms and dads.
For
Only to be done
science.
after dinner. Maddie wants some too.
She's like, dang
Sorry,
it.
Poochie.
That's really good.
Alright, Maddie, you want to hit the button to stop it?
Very good.
Is there? Oh, what's this?
There's still some more in there.
Alright, folks. From Miss Duggan, Mr. Manta, Mama Manta, and Maddie Manta. That's all we
Hi,
got for today.
guys.
Back to the slides. Oh, man, that made me want to go make some more. It did honestly taste really good. And I have to say, Miss Duggan definitely did a majority of the shaking there. I gotta confess. All right, let's recap what it was that we just saw, which was, first of all, simply that ice cream is a mixture. It's a mixture of milk, cream, sugar, and flavorings like vanilla or chocolate or whatever. So in today's, even though we called it a chemistry experiment, there were actually no chemical changes in today's experiment. We had things turning from liquid to solid, but that's a physical change, right? We had things turning from solid to liquid, the melting ice cubes, but that's also a physical change. And ice cream is just a mixture. There wasn't really any new substance created, no particles combining to form anything new. What we did learn, though, that had to do with chemistry, the reason why we had to have some background knowledge, was this whole deal with why we added the salt to the ice cubes. Adding salt to our bag of ice cubes lowered its melting point. And you can say melting point or freezing point interchangeably, either one works. That way, the ice could be cold enough to freeze the ice cream, right? If we had just used normal ice cubes, it might have been like 30 degrees Fahrenheit, and that wouldn't have been cold enough to freeze some solid ice cream. So instead, we had to add some salt, and by turning our ice cubes into salt water, we were able to bring the temperature of the ice cubes down to 0 degrees, and that's cold enough to make real ice cream. All right, at this point, I'm going to pause quickly and have you answer class for question 1. And I'm curious to ask you guys, what do you think would have happened if we hadn't added salt to the bag of ice? Would we have made ice cream? What would we have made instead? Go ahead, pause the video, answer classwork question 1 now. All right, moving along. I'm assuming you've answered it. I'd like to close out today. All I want to say to you guys is happy ice cream making. I also want to say to those families who are doing this at home, be sure to have a good ice cream shaking dance playlist ready to go. Like I said, we had Earth, Wind, and Fire and Chromeo. Please, when you're sending me pictures and videos, let me know also what your playlist was, what you enjoyed. You don't have to send me the entire 10 minutes of you shaking together the ice cream. You can just show the final results. But I am curious what everyone else listens to at home. All right, I'm going to wrap up with classwork question 2, and then we'll do an independent practice. But here's first this classwork question 2. It's a big question. The question is, we only have a couple more weeks of science lessons before school is over. What are some things about science that you still want to learn more about? Please take a second to really think about this question. Don't just say nothing. Take a second to really think about this question. Think through all the things you might associate with science. And tell me, it's your last chance for a while, if there's anything that you would still want to learn about. Pause the video and answer this classwork question now. All right, hopefully you got some good answers. We are moving right along to our independent practice to close out the day. All right, we've got 5 questions here. Some of them will look familiar. This is all the stuff that we just talked about. Pause the video and answer these 5 independent practice questions now. All right, I'm moving along. I'm assuming that you have now done that. Here are questions 6 through 10. For questions 7 through 10, you have to tell me the names of different properties. Hopefully you remember some of those properties that we talked about. Pause the video. Answer these 5 questions now. All right, and moving along from there. Oh my goodness, I forgot to put the answers. Well, I guess I wasn't very well prepared, so I'll have to do the answers manually. Number 1, is melting ice cream a physical change or a chemical change? Well, melting things is always a physical change, ladies and gents. Number 2, Maddie gets some water from the sink and changes its temperature so that it's now above water's boiling point. What state would it be in? Well, when you go above the boiling point, things turn to gas. So that would be a gas. Man, if you guys missed Mr. Mancha's messy handwriting, here you go. Number 3, Amy gets some ice from the freezer and changes its temperature so that now it's now above water's melting point. What state is it now in? Well, anytime you go above the melting point, things turn to liquid. Number 4, water freezes at 32 degrees Fahrenheit. That means 32 degrees Fahrenheit is water's freezing point. Could also say melting point. That would also technically be correct because things freeze and melt at the same temperature. And number 5, which law of physics says that matter can never be created or destroyed? That is our friend, the law of conservation of mass. Mass and matter can never be created or destroyed, just like energy. All right, let's manually answer questions 6 through 10. Number 6, the scientists whose job it is to invent new material that people can use to improve their lives are called materials scientists. I know it's not the most creative name in the world, but at least it tells you exactly what they do. Number 7, glass is totally see-through because light can pass through it. In other words, glass is highly transparent. That's the word we're looking for. Number 8, electricity can pass through metal easily. In other words, metal is highly conductive. Remember, conductivity is the property that describes whether things can transport electricity or heat. Oh, so that should just be my mistake. Conductive. Number 9, light bounces off mirrors very easily. In other words, mirrors are highly reflective. That means that something reflects light. It's very shiny. And number 10, you can stretch and squish Play-Doh without breaking it. In other words, Play-Doh is highly malleable. That's that property that we learned that means you can stretch and squish something. All right, now that we've got those 10 answered, go ahead as always. Star the ones that you got correct. Cross off and fix the ones that you got wrong, and tell me in today's independent practice which ones you got. And that is going to wrap things up for today, ladies and gents. It's exit ticket time. I'm wishing you good luck on the test. And like I said, I want to be showing you guys some music, because I haven't really shared much of my music library with you thus far. So here's another song for today. All of that dancing and shaking ice cream got me thinking about dance music. And one of my favorite, really awesome dancey bands is a group called Wolfpack. They have the song called Cory Wong. I'm going to link the link to it as today's cool thing. But man, if this song doesn't get you dancing, up on your feet and having a good time, I don't know what will. Alright, that wraps it up for today, ladies and gents. Good luck on the test tomorrow. So I'm not going to actually talk to you guys all the way until Monday. I will see you then for our final new unit. Take care.